Jai Hind, welcome to the course Network Analysis and Synthesis, and today I am going to discuss about the node and mesh analysis of this course. So, learning objectives of this today lecture is, before carrying out the node and mesh analysis, first we defined terminology being used in the node and mesh analysis. So, first we will discuss the various terms such as what is node, then junction, branch, loop, mesh, etc. So, first we will define these terms before carrying out the node and mesh analysis of any given circuit. Then we will discuss the dependent and independent sources. So, what is the difference between independent and dependent sources and how they are being presented in the given network? How you can identify that this source is dependent and this source is independent. And the last we will carry out the node and mesh analysis, which is the topic of today. With some examples, we try to explain the node and mesh analysis. So, first term is what is node? So, node in a network, in an electrical network, it is an equipotential surface at which two or more circuit elements are connected. So, this is the definition of node. Then what is the difference between node and junction? So, junction is a node where three or more circuit elements are connected. So, difference between node and junction is that at node there are two or more circuit elements are connected, whereas at junction there are three or more circuit elements are connected. So, we can say that all junctions are node, but every node is not a junction. So, this is the difference between node and junction. Then third term is branch. What do you mean by branch in a electric network? So, branch is that part of the network which lies between two junctions. So, the path between two junctions is called branch. Then loop. What is loop? So, loop is any closed path of the network. What do you mean by loop? So, loop is the closed path of the network. Then mesh. So, mesh, it is a minimum number of loops which covers all the elements of the network. So, it must be defined that it cannot be further divided into other loops. Okay. So, there is a difference between loop and mesh. Mesh is also a closed path, loop is also a closed path. But what is the basic difference? Basic difference between mesh and loop is that meshes are independent loops. If you select a mesh, that is a loop, that is independent loop, that loop cannot be further divided into other loops. So, all these terms we will explain by taking some examples. Then mathematically it can be calculated as number of mesh in a network is given by number of branches minus number of junctions minus 1. So, how many meshes are there in the network? Identify the junction, number of junctions, and at the same time also identify number of branches, and take the difference. We will get the number of meshes in a given network. Then there is another term, super mesh. So, what is super mesh? If there exists a current source in any branch of the network, then a loop cannot be defined through the current source, as we do not know what is the voltage across a current source. So, in case of the super mesh, we cannot apply the Kirchhoff's voltage law, we cannot take the apply the KVL because we do not know what is the drop across the current source. Then another term, supernode. So what is supernode? The supernode is region surrounding a voltage source which connects two nodes directly, is called supernode. So these are the some terminology, these are the some terminology which are being used in carrying out the node and mesh analysis. So these terms can be explained with the help of, suppose this is the given circuit, okay. Now find the number of nodes. How many nodes are there? Find the number of nodes. So node is a equipotential surface. So this is equipotential surface. So this is one node, this is another node, this is another node, okay, this is a node, and this is a node, okay. So basically there are 5 nodes, 5 nodes, A, B, C, D and E. So there are 5 nodes in this given example. How many junctions? So junction is a node where 3 or more circuit elements are connected. So here we can see that B junctions are B and E. So there are 2 junctions. Here at B we can see that R1, R3 and R2 are connected, and at junction E voltage source V1, voltage source V2 and R2 are connected. So in this given network there are 2 junctions. So 2 junctions. Then how many branches are there? So branches lie between the 2 junctions. So junctions are B and D. So what are branches? So this is one branch, this is second branch, and this is the third one. So 3 branches, 3 branches. R1 V1, one branch R2 second, and R3 R4 V2. So this is one branch consisting R1 V1, this is the second branch. So this is the first branch, this is the second branch, and this is the third branch. So there are 3 branches. So part of the network that lies between 2 junctions. So first we have to identify the junctions in the given network, and then we can identify or can recognize or can find out how many branches are there. Then mesh and loop. So any closed path is any closed path. How many loops? So number of loops, number of loops. So we look at the definition. Loop is any closed path. So there are 3 loops. Number of loops 3. What are they? Loop 1, first is A, B, E. Loop second E, B, C, D, E, and loop third A, E, A, A, B, E, A, A, B, E, A, okay, closed path. So E, A, B, E, A, B, C, D, E, outer loop. So there are 3 loops, any closed circuit. So in this given network there are 3 loops, A, B, E, A, E, B, C, D, E, E, A, B, C, D, E. So this loop and outer loop. But how many meshes are there? Meshes are independent loops. So minimum, so there are 2 meshes. Number of meshes, 2. What are they? Mesh 1. Mesh 1 is E, A, B, E, and mesh 2 is E, B, C, D, E. Okay, E, B, C, D. So this is one loop, this is the independent loop. So this is mesh number 1 and this is mesh number 2. So independent loops cannot be further divided into other loops. So this is the difference between the loop and mesh. And now you can find out number of meshes, number of branches. So there are 3 branches. How many junctions are there? 2. So 2 minus 1. So 2 minus 1 is 1 and 3 minus 1, that is 2. So there are 2 branches. There are 2 meshes. So this way we can find out. Now come to another topic, independent voltage sources. So basically an ideal voltage source is defined as a 2 terminal. So independent sources are 2 terminal device capable of providing a constant voltage across its terminals. The voltage across constant and independent of load current, and these are the symbols of independent voltage source, and this is the VI characteristics of independent voltage source. We can have the practical voltage source. It has some internal impedance, resistance is there, internal resistance. Here internal resistance is 0. So this ideal voltage source has 0 resistance, where practical voltage has some internal resistance. Then we can have the IV characteristics of practical voltage source. So this is the IV characteristics of practical voltage source. Then come to ideal and practical current sources. So these are here. These are the symbols of current source. Okay. These are the ideal current source. This is the practical current source. So ideal current source has infinite internal impedance, is infinite. Okay. Whereas practical current source has some impedance, internal impedance, and these are the characteristics of ideal and practical independent current source. So basically independent currents and voltage sources are 2 terminal device, whereas dependent sources, they are the 3 terminal device. So this difference between dependent and independent sources are because they are the 3 terminal device. So dependent sources are 3 terminal device and independent sources are 2 terminal device. So in any control source, this source voltage or current, depending upon the type of the source, is not fixed, but is dependent on the voltage or current at some other location in the network. So the control source is unilateral in the sense that input variable controls the output variable, whereas output quantities do not influence the input quantities, and these are the some symbols of dependent sources. So basically there are 4 types of dependent sources. Voltage control voltage source. So we can, voltage source has polarity and outside it is the Vin. So the magnitude of this voltage source is depending upon the magnitude of this Vin. Okay, so it is voltage source. So it is voltage control voltage source. The voltage of this source is controlled by this Vin. Now come to the voltage control current source. So it is a current source denoted by directions. Current source has direction and voltage source has polarity, and here it is controlling variables, which is voltage. So it is voltage control, and of which voltage? This voltage. So this current source is depending upon the voltage of this Vin. So it is called voltage control or voltage dependent current source or voltage controlled current source. whereas this is a voltage source and controlling variable is current, and current of this branch of this branch, this is I, this is basically I. So this is a current controlled current source, this is current controlled voltage source, and this is current controlled current source. So the variable is, controlling variable is current, and this is a current source, it has direction, this voltage source has polarity. So there are 4 types of dependent sources: voltage controlled voltage source, voltage controlled current source, current controlled voltage source, and current controlled current source. So there are 4 types of, and it is 3 terminal devices: input terminal, output terminal. Okay. So these are the some basics of node and mesh analysis. Now we try to understand node and mesh analysis with the help of some examples. So this is, suppose this is a given example, find the voltage V1 and V2 and current I. So this is this current I, using mesh and node analysis. So for the node analysis, first job is take a reference node. This is the reference node, and with respect to this node we take the voltage of other nodes in the given network. So if you are going to apply the node analysis, means you have to apply Kirchhoff's current law. So node, and for the mesh analysis we apply the Kirchhoff's voltage law. So there are 2 nodes V1 and V2. So apply Kirchhoff's current law at node V1. So we can see that here at V1 there are 4 elements, this 4 ampere current, 10 ohm, 3I current dependent current source. So this is basically CCCS. Okay, it is a dependent source, and these are the independent sources. So there are 2 independent current sources and 1 dependent. So it is current controlled current source, and current of this current source is depending upon the current of this branch I. So it is current control. So how many elements are there at V1? 4. So 4 current variables, and we can see that 4 ampere current is approaching towards node. So we know that what is the Kirchhoff's current law? The algebraic sum of current meeting at a node is 0. So incoming current is equal to the outgoing current. Basically it works on the principle of conservation of charge. So 4 ampere current is approaching, and V1 minus V2, that is the current flowing from V1 to V2 through say 20 ohm resistor. So because V1 suppose V1 is a high potential, so it is current is flowing from V1 to V2, so it is away from the node. Second current is V2 minus 0 upon 10 ohm, that is through this current, it is also away, plus 3I. This is the one equation. Now apply Kirchhoff's current law at node V2. So at node V2, how many elements are there? Again there are 4. 1 element, second, third and fourth. So V1 minus V2 upon 20, that is approaching towards node, plus 3I, this current is also approaching node, is equal to V2 minus, sorry, this is V1, this is V1, this is V1, okay. V2 minus 0 upon 5, that is away from 3. So this is V1 minus V2 upon 20, that is the current flowing through 20 ohm resistor. V1 minus 0 upon 10, that is the current through 10 ohm resistor. 4 ampere current is approaching, plus 3 and plus 3I. Okay, and this is the equation second. So V1 minus V2 approaching towards node V2, 3I is also approaching, V2 minus 0 upon 5, that is the away from the node V2, and 3 ampere. So how many unknowns are there? There are 3 unknowns, V1, V2 and I, and we have written 2 equations. So one more equation is also required. So third equation is I is equal to V2 by 5. So current through 5 ohm resistor is I, and which is V2 minus 0 upon 5. So it better write this way. Okay. So these are 3 equations, 3 unknowns. Using these 3 equations we can find out V1, V2, V3. So these are the equations you can write, and from first, second, third we can get V1 is equal to minus 10 volt, V2 is equal to 10 volt, and I is equal to 2 amperes. So solving these 3 equations we can get the values of V1, V2 and I. Now solve this circuit using the mesh analysis. So this circuit is very much suitable to apply node analysis. To apply mesh analysis, what we do, we just modify the circuit as per our convenient, so that we may be able to apply the Kirchhoff's voltage law. So we can modify. We have taken out the source transformation. So we can carry out the source transformation of this branch. We cannot carry out the source transformation of this branch because this is the controlling branch. So we cannot carry out the source transformation of this. However, we can carry out the source transformation of this branch. Remember, we can, because it is a control, it is a dependent part of the dependent source. The current of this branch is the current of this current source. Okay, so we cannot carry out the source transformation of this branch, whereas we can carry out the source transformation of this branch. So this circuit can be modified in this way. We carry out the source transformation. From this circuit we can carry out the mesh analysis. So mesh analysis, basically we apply the Kirchhoff's voltage law. So apply Kirchhoff's voltage law in the loop, apply Kirchhoff's voltage law in the loop. A, B, C, D, A. So starting from A to B, so A to B we are going, so it from minus terminal to plus terminal, so it is 40. Okay, then B to C, so B to C, and the current, suppose the current through B to C is I, so it is minus 10 plus 20 into I, because current is flowing from B to C, so here is plus minus. Okay, current flows from higher potential to lower potential, so B is at higher potential. Then C to D, so C to D it is a current controlled voltage source, okay, and current of this sources of this, so it is a voltage source, current control voltage source, it is a voltage source. So we are going from the negative polarity to positive, so it is plus 60I. Then D to A minus 5I equal to 0. One equation. So applying Kirchhoff's voltage law, we have obtained these equations. So we can see that here are two variables, one is I, capital I, and other one is small I. So we have to go for another equation because two unknowns, two equations are required. So other equations we can see here, if we apply the KVL, apply KCL, we have applied KVL, now KCL at node D. So at node D, I approaching and I is leaving and 3 ampere. So this is the second equations. So from the first and second we can get the value of this I and capital I and small I. So from on simplification we can get I and small I. Okay. Now in the question you have to find V1 and V2. So how can you get the V1? So V1 is basically this potential. So 40, we write the line equation. Write the line equation. A to B, so it is 40, okay, minus 10 I equal to V1. So we can obtain the I from these two equations. Writing this we can get the V1 and V2. V2 is 5I. So this way we can get the value of V1 and V2. So these are the so this way we can get the values of V1, V2 and I using the mesh analysis. So remember, applying the node analysis we use the Kirchhoff's current law, and applying mesh analysis we use the Kirchhoff's voltage law. So we can get this. Okay, now there is another question. Here find the current I0 using mesh analysis in the circuit shown below. So this is an example of super mesh because a current source is in between this close and this. Okay, so it is a super mesh. So we cannot apply Kirchhoff's voltage law in this loop or in this loop because we do not know what is the drop across 1 ampere current source. So basically what we do, we write the Kirchhoff's voltage law for the outer loop. So apply Kirchhoff's voltage law in the loop AB, C, D, A. So A to B it is 6 volt. Now B to C, so minus I0 into 1, so it is I0. And look at here, C, at C 1 ampere current is approaching and I0 is also approaching. So current through this branch is I0 plus 1. Okay, because I0 is approaching, 1 ampere current is approaching node C. So from C to D it is I0 plus 1. So what is the voltage across 5 ohm? So it is minus 5 I0 plus 1. Now here plus to minus, so minus 2 I0 equal to 0. So we can get the I0. So which is this way. So we cannot apply this is an example of super mesh, outer loop, and we can find the values. Okay. Now this is another example, find the node voltage and current Ix using node analysis. So this question has been asked 2 times in the AKTU and semester examination. So find the node voltages. So there are 3 nodes. So let voltages at node 1, 2, 3 are 2 and V3 respectively. Okay, apply KCL at node V1. So how many branches are there? So 3 ampere current is approaching. So 3 equal to V1 minus V2 upon 2 plus V1 minus V3 upon 4. This is 4 ohm. This is 4 ohm. This is 4 ohm. So 3 currents. So this is one equation. Apply KCL at node V2. So at node V2, how many branches are there? There are 3 branches. So V1 minus V2 upon 2, that is approaching node 2. V2 minus 0 upon 4, that is leaving the node 2. So this is equal to plus V2 minus V3 upon 8. Second equation, apply Kirchhoff's current law at node 3, at node V3. So how many elements are? 1, 2, 3. Again 3. So variables. So V1 minus V3 upon 4, that is approach node 3, equal to V2 equal to V3 minus V2 upon 8, that is away from node, or if you can write it, that is V2 minus V3 upon plus 2ix. So this is the third equation. So how many unknowns are there? There are 4 unknowns. So one more equation. So we can write ix is equal to, ix is nothing but it is V1 minus V2 upon 2. So 4 equations. So using first these 4 equations, we can get the variables V1, V2, V3 and current ix. So this question has been asked 2 times in the AKTU exams. So just we stop here. Thank you very much. Jai Hind.